Section 15 is going to be on lengths of arcs in areas of sectors. So there's a sector and the curved bit at the top is the arc. Now you think about an arc, and an arc is a bit of the circumference of a circle. So if I was to say, for example, that was 30 degrees and that the radius here was 7 centimetres, then the length of the arc is a bit of the circumference of the full circle. Now the full circle is 360 degrees, but we're only looking at a bit of that. How much is a bit? And it's 30. So it's 30 out of 360. Lots of the circumference of the circle, which is not in your formula sheet. You need to remember that one. And that's c equals pi d. So it's a bit of pi d. So 30 out of 360 times, if we take pi has been 3.14, or hit the pi button, multiplied by the diameter. Be careful, double the radius there, which is 7, and that'll give us 14. So put that into the calculator. And if I were to round that to one decimal place, that would be 3.7 centimetres. Let's try another one. So length of the arc is equal to a bit of pi d. So how much is a bit of the circle? 70 degrees. So 70 out of 360 multiplied by pi times the diameter. So 70 out of 360 times either the pi button or 3.14 multiplied by the diameter. The radius is 5, the diameter will be 10, and put that into the calculator. And this time to one decimal place, that is 6.1 centimetres. Okay, this one. Now, the angle that we're given isn't within the sector, it's out with the sector. That's 330 degrees. So we can quickly take that off the full turn to know that the angle in here is 30 degrees. And its length of arc equals 30 over 360 times pi d. 30 out of 360 multiplied by 3.14 of the pi button multiplied by the diameter, which is 16, and put that into the calculator. And to one decimal place, that's 4.2 centimetres. Okay, next one, we're going to find not the length of the arc this time, but the amount of surface that's inside the sector. That's the area of the sector. That's a completely different question. So the angle out with the centre is 220 degrees. So 220 off the 360, and the angle in the centre is 140 degrees. Now this time, crucially, we're finding the area of the sector. So it's the area of a bit of a circle. How much is the bit? 140 degrees. So a bit of pi r squared, because the area of a circle is pi r squared. Remember, that's another formula that won't be given to you. So 140 out of 360 times 3.14 at the pi button multiplied by the radius, which is 8, and we need to square that. Put that into your calculator. And to one decimal place, that's 78.2 square centimetres. I'm going to square those units because it's an area. Now look out for these questions coming up in a non-calculator paper as well, and practice them in that context. And here's one that we're going to try without a calculator. So let's think about the tactic for this one. 120 degrees in the centre, 3 centimetres area of a sector. So area of sector questions and length of arcs questions can come up without a calculator, so be prepared for that. Let's get the working down. So 120 out of 360, lots of pi r squared, and the question at that time is going to tell me to take pi has been 3.14 rather than use the pi button because I don't have a calculator. So it's 120 out of 360 times 3.14 multiplied by the radius squared. The radius is 3 squared. Let's go straight to 9 with that one. At that point, look for simplification. Now, 120 over 360, well, I can divide top and bottom of that fraction by 120. That comes right down to a third. 120 fits into 363 times. 1/3 times 3.14 times 9. Now what else can I do here to tidy this up? Well, 1/3 of 9 is 3, so then it's just 3 times 3.14. Take your time with that, 9.42 square centimetres. Okay, we can now think of a couple of questions that are just a bit trickier with lengths of arcs and areas of sectors, and that's essentially when we've been given the length of the arc and the area of the sector, but missing one of the components to get the answer. Now, typically what we can do with these questions is use changing the subject of the formula to help us proceed. So let's have a look at what that might be. So here's a sector, and this time I know that the length of the arc here is 20 metres. I'm going to say the angle in here is 30 degrees, and the thing we're looking for this time is to calculate the radius. So a more conventional question is you're given the radius, the angle at the centre, and you look for the length of the arc. We're given the length of the arc, we're given the angle at the centre, and we need to find the radius. So let's have a think about this one. So we know that the length of the arc is 30 out of 360 multiplied by pi times the diameter. And we know that that's the length of the arc, and we already have the answer for that. The length of the arc is 20. Now if we can get the diameter rather, we just need to half that, and that will give me the radius. So I just change the subject of the formula here. So I can get rid of the divide by 360 by multiplying by 360. I can then get rid of the times 30 pi by dividing by 30 pi, so it's just applying a little bit of changing the subject of the formula. If I throw all that in the calculator, I'll get a value for the diameter, and then I'll half that answer, so I'm going to give that a go just now. That gave me approximately 76.4 metres for the diameter. To get the radius, I just half that, and that will be 38.2 metres. Now this one's slightly different. This time I've been given the length of the arc again. I've been told the radius this time, but it's the angle at the centre I'm looking for. So the angle that I don't know and I'm looking for out of 360 multiplied by pi times the diameter will give me the length of the arc, which is 4. So it's x over 360 multiplied by, well, the radius is 5, which means the diameter is 10. So that's 10 pi is equal to 4. Let's use that theme of changing the subject of the formula again. So just take your time. So I can get rid of divide by 360 by multiplying by 360, so that's 4 times 360. I can then get rid of times 10 pi by dividing by 10 pi. Throw all of that into the calculator. And that will give me about 45.9 degrees. Okay, let's try a bit of working backwards, but with area of a sector. The angle at the centre is 120 for this one. The area of the sector is 100, I'm looking for the radius. So the area of the sector is a bit of pi r squared. So 120 out of 360 multiplied by pi times the radius squared is equal to the area of the sector, which I know is 100. I can then multiply by 360 and get rid of that, so that's 120 pi r squared is equal to 100 over 360. I can then bring the 120 pi down, so it's 120 over 360 times 120 pi, all down the bottom. And then finally, to get the radius, I just take the square root of all of that, and that will give me r equals 0.03.